Your body is eating itself right now. Not metaphorically, literally. After 72 hours without food, your liver exhausts its glycogen reserves, and your muscles begin dissolving to fuel your brain. You become slower, quieter. Then you start making decisions that would genuinely horrify you today. Now imagine that isn't a medical emergency. Imagine it's just winter. For most of human prehistory, starvation wasn't a disaster. It was a season. Researchers studying isotopic signatures in ancient human bones have documented repeated cycles of nutritional stress. Ancient people starved, partially recovered, starved again, year after year across their entire lives. And when food ran out completely, not just scarce, completely gone, ancient humans did not wait. They adapted, they innovated, and they did things that are almost impossible to explain to a species that has never experienced genuine hunger. That is not desperation. That is systematic engineering applied to a recurring problem. By the end of this video, you will understand exactly what ancient humans consumed when there was nothing left to consume, how they found calories in things most people today would not recognize as food, how starvation permanently rewrote human biology, and why the hunger signal firing inside your brain right now is older than your species. Most people imagine prehistoric hunger working like a modern food shortage. The supermarket runs low, prices rise, people panic. That is not how this worked. Not even close. Because prehistoric food supplies didn't have warning signs. They simply stopped. Megafauna migrations were unpredictable. A herd that arrived every autumn for 100 consecutive years could simply not appear one season. No explanation, no substitute, just silence where the animals used to be. Archaeologists studying Palaeolithic settlement patterns at sites across Europe and Central Asia have found evidence of rapid, repeated abandonment. Entire campsites left mid-occupation, tools still in situ, hearths half-constructed. People departed so quickly they left equipment behind. That detail matters. It tells you something specific about the pace of food collapse in the prehistoric world. Not gradual, not managed, sudden. One week there was food, the next week there wasn't, and everyone immediately understood what that meant for the next several months. Here is the part most coverage skips. Ancient humans were not wandering randomly across landscapes hoping to stumble into food. Researchers at the Max Planck Institute for Evolutionary Anthropology, studying Neanderthal seasonal behavior, found strong evidence of deliberate resource scheduling. Specific sites used at specific times of year, fallback locations identified in advance, caloric reserves mentally accounted for. These people were running a logistics operation entirely inside their heads, which means when that operation failed, it didn't erode gradually. The entire structure collapsed at once. In the moments before full starvation, ancient groups made a decision that governed the next several months. Not the decision to hunt harder, the decision about who ate first. In any group running out of food, every meal becomes a negotiation. Researchers studying behavioral economics and impulse control have found that food-related decisions activate some of the oldest and deepest reward circuitry in the human brain. Consistently document the same priority structure. Active hunters ate first, children second, the elderly last. Not because ancient people were callous, because that was the calculation that kept the group functional long enough to locate more food. Dry observation. Nobody wrote that policy down. Nobody held a meeting. Everyone simply understood it, which tells you something about how deeply that survival arithmetic was embedded in the human social structure, and how long it had been running before anyone thought to question it. Before ancient humans reached the truly extreme, there was a long middle phase. Under normal conditions, the caloric return barely justifies the work, and the inventory is considerably stranger than most people expect. Researchers studying plant residue on ancient grinding stones have found evidence of bark flour. The intercambium layer of birch, pine, and elm contains enough starch and simple sugar to yield modest calories when stripped, dried, and ground. It tastes, by every historical account, exactly like you would expect bark to taste. Archaeologists in Scandinavia have recovered grinding stones with bark residue at Mesolithic sites dated to periods of known climate stress. This was not random experimentation. This was a practiced technique, passed forward across generations, a recipe in the fullest sense of the word. For tree, bark was not the only unusual option. Researchers analyzing ancient dental calculus, the hardened plaque preserved on prehistoric teeth, have identified grass seeds, dried lichen, fungal spores, and deposits of specific clay types in the diets of individuals under documented nutritional stress. That last item requires explanation. Clay, deliberate consumption of mineral-rich soil. Geophagy has been documented in dozens of ancient populations by physical anthropologists studying skeletal mineral profiles. Certain clay types bind to the toxins in plants that would otherwise be poisonous, effectively detoxifying a food source that had previously been inaccessible. Not because ancient people had a chemistry textbook, because someone tried it during starvation, survived, and that information traveled forward. Dry observation, thousands of years of accumulated survival knowledge, and the headline contribution is, we determined which soil was digestible, and yet the species is still here, which does say something about the method. Insects provided an emergency food source that modern audiences consistently and dramatically underestimate. Research on caloric density across food categories has shown that beetle larvae, moth caterpillars, and ant eggs can contain more usable protein per gram than red meat. A concentrated handful of grubs is nutritionally comparable to a small portion of venison. Archaeological evidence from cave sites in southern Africa and Southeast Asia shows insect remains in human dietary contexts dating back over 100,000 years. Not a last resort for some populations, a reliable supplement, and during starvation periods, potentially the margin between survival and death. Winter root foraging was nothing like the clean, manageable process it appears in modern reconstructions. Tundra zone foraging during true winter meant excavating through frozen ground, using bone or antler tools, searching for caloric stores that plants deposited underground during autumn. Researchers at sites in Central Europe have found wear patterns on ancient antler tools, consistent specifically with frozen ground digging. Someone designed a dedicated tool for retrieving food buried under frozen earth. That is not desperation. That is systematic engineering applied to a recurring problem. But here is the problem with the entire inventory: bark, insects, clay, frozen roots, emergency fungi. None of it provides enough calories to sustain an active adult through heavy physical labor in cold weather. You can eat everything on that list and still starve to death, just slower. Which is why, when the pressure increased, ancient humans shifted focus entirely away from protein and towards something far more valuable: fat. Here is what most prehistory coverage gets wrong. It shows ancient humans hunting large animals and assumes the primary goal was meat. It was not. And during winter starvation, that fat was worth more than anything on the surface of the animal. But researchers studying bone grease extraction at Cree and Inuit archaeological sites, bones were smashed open systematically, from every angle, with focused repetition. The target was marrow. Fat, concentrated caloric fat contained inside bone, and during winter starvation, that fat was worth more than anything on the surface of the animal. Archaeologist Randy Suravel's analysis of bone processing at Pleistocene sites in North America found evidence of marrow extraction from bones so small and calorie marginal that under normal conditions they would be discarded entirely. The tarsals of hares, the foot bones of birds, bones where the energy required to crack them approached or exceeded the energy yielded by the marrow inside. Unless you were desperate, then every bone was worth attempting. Imagine picking clean the foot bone of a bird, not because you are mildly hungry, because you are watching a child in your group lose the ability to walk from fat deficiency, and this is the only caloric option remaining. That is what those small fractured bones actually represent, not primitive eating habits. Clinical desperation translated into tool marks. The importance of fat also explains something that puzzled archaeologists for decades. Why do ancient sites show evidence of large-scale bone rendering? Boiling bones in water and skimming the grease from the surface is a laborious process. You need fire-resistant containers. You need sustained heat. You need time and fuel. Under normal conditions, the caloric return barely justifies the work. Researchers studying demographic patterns in documented historical famine populations maintaining continuous knowledge of starvation-era techniques, found that a single large femur rendered over open fire could yield enough fat to provide several hundred calories. In a winter with nothing else available, that was a meaningful margin. Dry observation. The entire recipe is 3 steps. Find bone, boil bone, drink the surface. And yet the sequence of reasoning required to arrive at that process under those conditions represents a genuine cognitive achievement. Hunger, it turns out, is an unusually motivating engineering brief. This is also where ancient humans began managing animal carcasses in ways that reveal considerably more planning than popular depictions suggest. Researchers studying site assemblages at Upper Paleolithic locations in France and Russia found evidence of deliberate caching. Animals killed and stored in frozen ground, then retrieved weeks or months later as needed. Natural refrigeration, controlled inventory, these were not people stumbling through landscapes reacting to whatever appeared. They were managing a reserve. But even fat had a finite limit, and when the marrow was exhausted and the rendered bones were empty and the cached carcasses were fully consumed, ancient humans moved into territory that required a different category of decision entirely. And this is where most coverage stops. This is the part of human prehistory that most channels choose not to cover. Not because the evidence is unclear or contested, because the evidence is specific and well-documented and genuinely difficult to process. And most productions decide the reaction isn't worth it. We are going to cover it, using the same language the researchers use. Because an honest account of what ancient humans did when food ran out completely requires it. Skeletal analysis at multiple European Paleolithic sites has documented what bioarchaeologists describe as processing marks consistent with defleshing. Cut marks on human bones matching, in angle and pattern, the cut marks found on animal bones at the same sites. The same butchering geometry, the same marrow fracture signatures. Survival cannibalism, consumption of the already deceased during severe starvation. Researchers at Gough's Cave in Somerset, England, and Fontbrégoua Cave in southern France have documented this evidence with forensic precision across peer-reviewed publications. This is not speculation. This is physical evidence analyzed by multiple independent research teams. The anthropological term is crisis period resource utilization. The accurate plain language term is considerably less neutral. But the crucial context, the part most coverage omits, is that this was not a cultural practice, not a ritual, not something these populations did casually or early. It was the same calculation that led someone to crack a bird's foot bone for traces of marrow. When every available option had been exhausted, the body in front of you contained calories. Some people made that calculation. Then they kept walking into the next season. Researchers studying mobility signatures in late Upper Paleolithic. The Donner Party, the Andes crash survivors of 1972, siege populations across medieval Europe, consistently find the same sequencing. Survival cannibalism occurs almost exclusively after multiple other strategies have already failed. It is not an early adaptation, it is the final one. Which means the evidence of it in prehistoric sites communicates something specific. Not that ancient humans were fundamentally different from us, that they had already tried everything else. But cannibalism was not the only adaptation at the edge of starvation, not even close. Researchers studying infant mortality patterns across Paleolithic populations have identified rates of neonatal death that skeletal analysis cannot consistently attribute to natural causes. Physical anthropologist Marta Mirzon-Lar and colleagues working at sites in East Africa have documented evidence suggesting selective infanticide during acute resource collapse. This is difficult material to hold. The context is not optional. These were not casual decisions. These were adults watching their existing children lose weight beside a dying fire, calculating whether they could keep a newborn alive on resources they did not have. Ancient groups also made survival decisions about their elderly members, not killing. Separation. Researchers studying metabolic genetics have found that populations with documented histories of severe ancestral famine. Assemblages have found evidence of elderly individuals camped at distance from main groups, provisioned minimally, traveling on separate routes. The anthropological term is consensual senicide. Elderly members of some groups voluntarily separated when they judged their continued presence was reducing the group's overall survival probability. Some researchers believe this practice carried cultural formalization, specific words, understood rituals, recognized protocols. The archaeology cannot confirm that, but that it occurred is not seriously disputed in the literature. Dry observation. That is simultaneously one of the most sophisticated and the most costly things human intelligence ever produced. The ability to model your own value to the group, run the calculation honestly, and act on the result. It requires abstract reasoning, genuine empathy, and a degree of self-abnegation. That is essentially impossible to fully comprehend from the standpoint of a civilization with heating systems and retirement funds. Imagine standing at the perimeter of camp in complete winter darkness, watching your group move away from you, understanding exactly why, agreeing with the logic, turning and walking in the other direction. That happened in specific places, in specific winters, by specific people who are, in all probability, somewhere in your ancestry, and whose names are permanently gone. Here is where this stops being ancient history, because the events in this video did not happen to abstract strangers in a disconnected past. They happened to your ancestors, repeatedly, over hundreds of thousands of years of recurring winters, recurring failures, recurring calculations, and that left marks, not memories. Biological edits, actual molecular changes to the human body and brain that are still operating inside you right now. Researchers studying resource-sharing behavior in forager societies, both historical and archaeological, particularly populations in sub-Saharan Africa, the Arctic, and the Pacific Islands, show significantly higher frequencies of what geneticists call thrifty genotypes, gene variants that make the body exceptionally efficient at converting caloric surplus into stored fat, and exceptionally resistant to releasing that fat during periods of moderate restriction. This is not coincidence. These are evolutionary signatures of repeated starvation. Your genome carries the fingerprints of every winter your ancestors survived and every winter they almost did not. The hunger hormone ghrelin, the signal that generates the sensation of being hungry, is now understood by endocrinologists to be an ancient system calibrated not for mild appetite, but for emergency caloric recovery following severe depletion. It does not simply produce hunger, it produces urgency, mild anxiety, a low-level compulsion toward food that is difficult to override with conscious reasoning. You experience that because your ancestors experienced it, and the ones who felt it most acutely, who responded to it most immediately, survived. This explains something that has genuinely puzzled nutritional researchers. Why is it so difficult for modern humans to stop eating when food is present and appetite is already satisfied? Not because of individual weakness or failure of discipline, because stopping is a new behavior. For virtually the entire span of human evolutionary history, the correct response to available food was always identical. Consume as much as possible immediately, because the interval before the next available food is unknown. That instruction is still running in your brain. It simply has no productive application in an environment where food is continuously present. Researchers studying Palaeolithic bone assemblages at sites across Europe have documented a consistent, unmistakable pattern. Systems that predate the prefrontal cortex's capacity for deliberate rational override by millions of years. You are, in a very literal neurological sense, negotiating against evolutionary programming every time you decide you have had enough. Dry observation. Evolution has been running this particular subroutine considerably longer than you have. The odds are not entirely in your favor, and the playing field is not level. The behavioral residue extends beyond hunger signals. Psychologists studying the long-term effects of ancestral famine exposure, including populations whose grandparents survived documented 20th century famines, have found elevated food anxiety, food hoarding behavior, and persistent difficulty regulating eating in response to actual caloric need rather than emotional state. Your relationship with food was partially authored by events that concluded thousands of years before your birth. Not metaphor. Documented intergenerational biological inheritance operating through epigenetic and genomic mechanisms. But the strangest legacy may be the social one. Anthropologists studying gift economies in forager societies have documented one universal behavior across every studied population on every inhabited continent. When a hunter returns with large prey, they do not eat alone. They distribute the surplus across the entire group, including individuals who contributed nothing to the hunt and cannot immediately reciprocate. This looks like generosity. Researchers now largely believe it is insurance. The logic is ancient and elegant. If I share my surplus today and you share yours when my hunt fails, neither of us reaches the threshold that forces the worst decisions. Anthropologist Kim Sterelny's work on cooperative foraging has demonstrated that reciprocal, sharing behavior is the single most consistently documented trait across all known hunter-gatherer populations throughout the archaeological and ethnographic record. Not cultural, structural, a behavioral solution to the starvation problem encoded so deeply into human social instinct that it survived every layer of civilization built over the top of it. You still do it. Every time you split a meal without calculating the division. Every time you bring food to someone who is ill. Every time you feel genuine discomfort watching someone go hungry while you have surplus. That discomfort is not modern civic feeling. That is a 200,000-year-old social contract encoded in neural circuitry that existed long before language, operating exactly as it was designed to operate. The real story of ancient human starvation is not a story of suffering. Not primarily, it is a story of solutions. Costly, creative, sometimes irreversible solutions built by people operating under conditions that would reduce most modern humans to paralysis within days. They found calories in bark and clay and insects and frozen roots. They engineered bone-rendering techniques in darkness and cold with hand tools. They made decisions about who survived and who did not, and they carried those decisions forward into the next season and the one after that. And then they kept going for another 1,000 years and another, until eventually one of them became your ancestor and passed to you a body and a brain optimized in ways you will never fully map for a world where food might simply not exist tomorrow. The next time you eat past the point of hunger, now you know why the impulse exists. The next time you feel low-level anxiety about having enough food, even when the refrigerator is full, now you know where that anxiety was trained. The next time you instinctively pass food to someone else without thinking, now you know what that reflex actually is. Not generosity, not culture, something considerably older than either. Your body remembers every winter your ancestors survived, every cache of marrow dug from frozen ground, every bark flour loaf ground in the dark, every terrible calculation made beside a dying fire with no good options remaining. Somewhere in the architecture of your hunger, the ancient ones are still running the numbers, still scanning the horizon for the herd, still making sure there is enough left for everyone. They just have absolutely no idea what to do with a refrigerator.